Hey guys, welcome to Simplilearn's YouTube channel. Today we will learn the loops in Java. In this particular tutorial, we will understand the fundamentals of control statements by using while loop, do while loop, for loop, enhanced for loop, and nested for loop. I hope I made myself clear with the agenda, but before we begin, make sure that you have subscribed to our YouTube channel and hit that bell icon to never miss an update from Simplilearn.
Hello guys, and let's get started with today's topic, which is about understanding the loop statements in Java. So first of all, understand why do we need loop statements. So generally, whenever you are dealing with some data structures in Java, which can store multiple elements, for example, we saw array, which can store multiple elements. String is also basically technically a character array, which is storing multiple characters. So whenever you have these kind of data structures where you have multiple elements being stored in the same, then in that case, you would like to have a way to iterate or access all of the elements in a seamless fashion. One of the ways is to access them individually one by one, but that's too much of work. That's too much of code. There has to be a simpler way of accessing all the elements one by one if I want to. And that's where the majority of the use cases for using loops coming to picture. Now, Java provides multiple constructs to write loops in Java. There is a while loop, there is a do while loop, there is a for loop, there is also an enhanced for loop. And in the previous versions of Java, a use case of iterator was also very popular. So there are multiple ways in which you can actually iterate over a collection and access all the elements of the collection one by one. And you can use it to multiple useful cases. For example, if you have a huge array of employee salary and you want to give bonus to each of the employees and add the bonus to the salary, then you need to do this addition for all the employees. It would be nice to have to return a while loop, and the while loop can automatically access all the employee salary one by one and keep adding the bonus to the salary. This would be an easier way to do this rather than individually updating each employee's salary. And the first loop statement we are going to understand is a while loop. So the syntax of while loop is very straightforward. You write the while keyword, you enter the actual condition which will be evaluating to a Boolean true or false. So you write the expression which will be a Boolean expression, exactly similar to the conditions which you use to write in your if statements. So you write your condition which will evaluate to either true or false, and then you write your statement. And these statements will keep executing till the time this particular expression evaluates to true. So generally the way it works is that it will enter the while block, it will evaluate the expression. If the expression becomes true, then the statements inside this particular while block will be executed. And after the execution of the statement, it will again go back, again evaluate the expression. We call them steps basically. So it will go to the next step, again evaluate the expression. If this still holds true, it will again go inside, execute the statement, move on to the next step. It will again go to the evaluation. So this loop will continue to go till the time this condition will hold true. If it still doesn't make sense for you, don't worry, we will have a demo of it to make you understand how to use the while loops. And maybe it's a good idea to switch to the IDE and look at an example of it. So I have already created while demo for it. Here it is. It looks very small and simple, but it will get to the point where we can understand how and why will we be using the while loops. So I've created a while demo class. I've added a public static void main method here, which is the entry point. I have declared a variable which is int count equal to 1. So the count value is 1 right now. And then I'm writing a condition here. I'm saying while count is less than 10, do this. So it will print the current value of count. And after that, I'm using the post increment unary operator. If you remember, we covered this in the previous sessions. What is the meaning of this? It basically will increment the value of count by 1. This expression is equivalent to if I write it in this way. If I write count equal to count plus 1. This is exactly the same as this, no difference. So this will have the same impact. I will just remove this line because we already have the count plus plus here. So if we try to understand this, we are basically incrementing the count and then checking the condition again. So at first time, it will be 1 less than 10. Yes, that is true. It will go inside and print the count value, the current count value, which will be 1, and then it does count plus plus. So now the count value becomes 2. It will again go back here, again check the condition saying is 2 less than 10? Yes, that is true. So the while condition again becomes true. It will again go inside this, print the current value of count, which is 2, then do count plus plus. So it will again increment the value of count. So now the count value becomes 3. Again go back here at condition and saying is 3 less than 10? Yes, that is still true. Again come here, print the 3. Again go here, make count as 4. 4 less than 10, prints 4. Again count plus plus, count becomes 5, and so on and so forth. It will keep doing that till the value becomes 10. So at a step when count plus plus results in the count value being updated to 10, it will go here and say is 10 less than 10? Now that is not true because 10 is equal to 10, but 10 is not less than 10. So this condition will become false and it will exit of this while loop and it will come here and it will execute if there was anything written after the while loop that will be executed. So that's the idea, that you want to do something till a particular condition holds true. Then you can use the while loop, define your condition and execute the statements and try to do something which changes the state of this condition. Here I'm changing the count so that every time a new evaluation happens. If I comment this will result in an infinite loop because 1 will always be less than 10. I will not be incrementing the count here and it will keep running forever. It will never stop. It will just keep printing 1, 1, 1 every time till your computer program runs out of the memory. So always remember not to end up into an infinite loop. That's probably one of the biggest mistakes any beginner programmer does. So please try to be aware of that particular loophole, not try to run an infinite loop. Always try to write something in the code block which can change the state of the condition, and also make sure that that state condition sometime should become false. You should also make sure that that always becomes false, because if I do this, then this condition will always remain true because it is already 1, then it will become 0, then it will become -1, -2, -3, so on and so forth. But that value of count will forever be less than 10. And again, you will never be able to exit this loop. Your program will be stuck in this loop till your program runs out of the memory. So always remember to write a statement or a statement of execution in your code block, which can change the state of the condition, which results in some eventual time when this condition becomes false. This condition has to become false eventually, otherwise you will never come out of the loop. Always remember that. So if we run this program now, let's observe the output. So we can see here this particular statement is printed for 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. After 9, the moment the count plus plus resulted into the count value becoming 10, it checked that condition and then it just came out of the loop because 10 is not less than 10 and the condition became false. So always do something inside your code block which results at least of one scenario where this condition becomes false. And that is how you can use the while loop. Now you can see this is a pretty generic code and you can write any kind of condition here, write any code you want to execute here, and then do something to change the state of the condition as well in a positive way, in a way which results this particular condition to be false at some point of time. And then your while loop will run fine. So this is all I wanted to cover in terms of the while loop. Hello guys, let's get started with today's topic, which is about how to use do while loops. So let's understand when do we need that and how do you actually use that. Let me switch to the Java documentation and if I can find some syntax of it as well. Yep. So as you can see here, if I just highlight this portion, this is how you actually write a do while statement block. So you write do, you start a code block, you write some executable statements, and then after the code block ends, you write a while expression and end it with semicolon. This is the syntax basically. It starts with do or curly braces, some executable statements, a while block or a while statement basically with an expression ending with a semicolon. Let's understand this with the help of a program to understand the structure better. So for this, I have created a sample program here, which is called do while demo. Again, having a public static void main method, and it has a variable which is count and it is initialized as 1. Then I write do. I write this code block or the curly braces, and then I am just printing the value of count. Then I am incrementing the value of count, and then I am writing a condition which says while count is less than 10 and semicolon. If you compare this with the previous demo we ran, if I just put them side by side, we had while condition statement and the state change condition. Here we have do statement, condition change statement, and then we check the condition at the end. So the idea is that if you have a use case where before you even evaluate the condition, you want to print something, even before you evaluate the condition. If you want to do something, in that case, you will use the do while loop. Even before the actual while loop starts, if you want to execute a statement, you will use do while loop. For example, if you want to print the initial value of the count even before the condition checks, then you can use do while loop. If that is not your use case, you can use a simple while loop, which is described here in this program. So coming back to the do while, so I say do, and then I'm saying print this particular statement without checking anything. This condition will be executed for the first time without any condition check at all. This will just work as is, like a normal Java statement. After that, I'm incrementing the value of the count, and then I'm checking the condition. So remember, when this particular condition is being checked, the first increment has already happened. But in the while case, we did the comparison before even the first increment. The first comparison happened with the original value of count. But here, the first comparison is happening with the incremented value of the count. Hope you get the difference in a better context now, that you will use this when you want to write some initialization code before you actually hit the condition. So this condition will be evaluated with 2 less than 10, and then the value will be printed. Let's print this example, and we'll also try to play around with this example a bit more to build our understanding better. If I run this program, there is no difference in output if you compare this with the previous program we ran for the while. So it prints the count value. So this is coming here. Then it increments the value. Then it checks the condition saying is 2 less than 10. Yes, that holds true. If that holds true, it will go back to statement number 9. Again print this. Again do an increment on the count. And again check the condition with the updated value of the count, which will say 3 less than 10 now. Similarly, print the value, increment, check. This will continue to happen till this particular condition becomes false. And once this condition is false, it will exit out of this whole do while loop, and it will go to the line number 12. And if you have any statement written there, you can that statement will be executed in this case. So let's try to change some values here, and let's see if we can make sense of this program if we change the value. Let's say if I put 11 here, what will happen now? Let's run this program. You will say now you will see that this particular output is displayed which says count is 11. So what happened here, that count was 11. It entered the do while block. It went to this particular statement which said count is 11. Then it incremented the value. So the value became 12. And obviously 12 is not less than 10. So it did not print it again. It only printed once, even if the first time the condition was checked, the first condition execution itself resulted in false. Still, line number 9 got successfully printed. And that's the whole idea behind using the do while. What if I change this value to 10? Let's see what happens. And after that, we'll run one more combination to just make it more interesting. This time again, count is 10. Line number 10 will be printed as count is 10. Then at line number 10, the count is incremented to 11, and 11 is not less than 10. So in this case, the loop ends and it will move out. Now, what happens if I do this? If I say less than equal to here, let's run this program and interpret the output. Now, again, only one statement is printed because in this case, the count is 10. 10 is printed here, and we are saying 10 plus 1, 11. 11 is still not less than equal to 10. And that's why the loop just exits. Let's make it 9 and see what happens. Now you see two values. So count is 9. It enters the do while loop, goes to statement number 9, prints the current value of count, which is 9, then increments the value to 10. Then at line number 11, this while statement is executed and the condition is checked. Is 10 less than equal to 10? Yes, 10 is not less than, but 10 is equal to 10. So this condition will hold true. It will go back here. Print count is 10. Make count 11. Again, check the condition. Is 11 less than equal to 10? No, it's not. And then the condition will return to false and loop will be exited. So hope this will give you a better understanding now, since we ran different permutations and combinations of the values and we saw when this will be executed and when this will not be executed. But the bottom line is very straightforward, that whenever you want to write some pre-processing logic, even before checking the very first condition of your loop, then in that case, you will be using a do while loop. Otherwise, a normal while loop or a for loop will absolutely work fine. Hello guys, let's get started with today's topic, which is about for loops in Java. So far we covered about while loops and do while loops, and we also saw different examples of using different types of data structures like arrays. But one of the core requirements whenever you are working with any kind of collection is to iterate over it. Exactly similar to what I explained in the do while and while lectures, that you would often require to iterate over a collection or a data structure. And for that, one of the most sophisticated and easiest way to do that is using for loops. So let's understand the syntax of for loop first, and then we will also look at an example of it in the Eclipse IDE. So I have just opened the official Java docs here. So if you see, this is basically the syntax of a for loop statement. So let's understand it. And let's also try to compare it with a while loop so that we can understand how it compares with the while loop. So if we see the syntax, we first see the term initialization, then we see the term termination, and then we see the term called increment. Now, if I try to compare it with a while loop, there also you basically did these three things. You first initialized a variable outside the while loop, which is called initialization, and then you wrote a condition, which is your termination condition. You wrote a condition saying, let's say, while I is greater than 10 or while I is less than 10. So that is the condition, which is also the termination statement. The loop will continue to execute till that condition evaluates to false, and that's when the loop terminates. That's why we call it as termination. And then the third piece of it is the increment, the I++, which we used to do in the while loops. So these three portions together make or constitute any kind of loop in any kind of programming language. And for loop, if you see, the kind of code which you use to write in a while loop in multiple lines, where you first initialize a variable, then you write a condition in the while block, and then inside the while block, you use to increment the variable. All of that can be done in a single line in the for loop. And that's why I said it is the most sophisticated and easiest way to write loops in Java. So you write all of these three things, the initialization, the condition, and the increment or decrement values in the single line, and then you start with the curly braces and you write the code which you want to keep executing till the condition evaluates to false. That's the basic syntax of it. So let us try to understand this with the help of an example. So here I have opened a class which is called for demo, and this is a class which will demonstrate the usage of a for loop. So again, we have a public static void main method, which you can see here, which is the entry point. And then I use the keyword for. I put standard braces or the brackets, and then I do the initialization. So this part is the initialization part. You initialize the variable. So I just say int I equal to 1, initialization done. You end it with a semicolon so that it is a single statement understood by Java. And then you write this condition, which is your evaluation / termination condition. So this condition is basically the deciding factor of how long your loops should run. It's exactly similar to what you used to write in the while block. If I just show you the example, this is what we used to do. So we did the initialization at line number 7. Then we wrote this termination condition inside the while syntax or the construct. And then we did the increment here. So we are doing all of these three steps, but we are doing it in a single line. So this is the condition, and then we write our increment or decrement values, which are going to change the evaluation condition every time at every step. So we are saying I++. So Technically, what I am saying here is that start with I equal to 1 and then check the condition I less than 10. So in the first step, it will be checking if 1 is less than 10. If the condition holds true, go inside the for loop, execute the statement at line number 7, and then go back to this particular statement. So we do I plus plus. So I becomes 2, and then you again go back to the condition. And again you check if 2 is less than 10. Yes, it is. So again you go inside the for loop and do whatever is written there. There can be multiple statements here. For now, I have just written one system.out.println. So that happens. And once all the execution is finished inside the block, it will again go back to the increment. Does the increment, so 2 plus 1 becomes 3. Again does the evaluation. And if the condition holds true, it will again go inside. So this will continue. This condition checking, execution, and increment will continue till the time this condition holds true. The moment this condition becomes false, the control will come out at line number 9. So that's the basic anatomy and control flow. It's very important to understand the control flow of a for loop. Otherwise, you might end up into a program which is forever running and which will just eat up all the memory available in your JVM. So be very sure of what you write in your for loop. Be very sure of especially these two parts, the condition and the increment or decrement. So this is very important piece. The initialization happens only once, and then this condition evaluates. If the condition holds to true, some code executes, goes back to the changing statement, which can be an increment, decrement, whatever, and again compares the updated value with the condition. So this will keep happening. Let's run this code to interpret the output. So I will right click, go to run as Java application. And if I interpret the output here, I can see that it started with count is 1, 2, 3, 4, 5, 6, 7, 8, and 9. It stopped at 9. So what happened there? Let's try to evaluate the termination condition. So let's say I has become 9 and 9 is less than 10. So it goes inside and it prints count is 9, which is I. Then it goes here and it says 9 plus 1. I plus plus means 9 plus 1, the current value of I plus 1. It becomes 10, and then it again compares the condition. So now 10 is not less than 10. 10 is equal to 10, but it is not less than 10. So the condition becomes false, and count is 10 is never printed because this condition has become false. It will jump out. So let's say if I do this, if I put an equal to here, and if I now execute the same program, this time I will see 10 here. And because I have said that, okay, check the condition, if 10 is less than or equal to 10, that will become true. It will print count is 10. Then it will increment and the count will become 11. The I will become 11. And then it will check 11 is less than or equal to 10. No, it is not. So condition becomes false and the control comes out of the loop. So that's how you should always try to interpret the loops. You can also run some infinite loops. For example, if I say I equal to 1, I leave it that, and I say I minus minus. So what happens? I equal to 1, 1 is less than 10. Yes, it goes here, prints the value, and then I decrement the value. I don't increment the value, I decrement the value. So whatever value comes out will always be less than 10, and this loop will run forever. For fun, let's try to run this, and I will have to kill this program manually, but just to show you what happens and what you should not do in your Java program. So you see, it will continuously keep printing the values till the program runs out of memory, till it eats up all the available memory. It is forever running. It will never stop because the condition will never evaluate to false. This condition will forever be true. So the loop will run forever. So I'm just going to kill the program, but this is something which you should avoid whenever you are writing Java code. And this happens quite often with beginner programmers. Hello guys, and let's get started with enhanced for loops in Java. We generally use the enhanced for loops for scenarios whenever we have to iterate over a collection of items or an array of items. Those are the most popular and common use cases of using enhanced for loop. And this for loop is even simpler. Like I said, it's even simpler than writing a classic for loop. And the syntax is simply like this. You again start with for, put the standard brackets, and then let's start from the rightmost because then I will be able to explain it better. You specify the collection in the rightmost side of the bracket. The collection can be an array, it can be a list, it can be a map. So whatever different kind of collections which are available in Java, and we are going to cover collections in detail. So don't worry if you don't understand what are lists and what are maps and what are sets. We will go into detail of each of these one by one in the upcoming sessions. But the idea is that you put the collection to the rightmost, then you put a colon, and then you put a representation of the member of this collection. So for example, here this numbers is basically an int array. So this int array means that this array can only hold integer numbers, and that's why we write int here, because this array is only having integers. Then we put any placeholder variable name. This can be anything. You can even write it as I if you want to. You can write it as anything, any variable name which you want to write. This is a temporary variable. So now this code is going to execute in a manner that it is going to iterate over this array one by one, starting from the first element, going till the last element. You don't need to write any initialization code. You don't need to write any termination condition code, and you don't need to write any increment or decrement code also. And how these three values are actually taken care of, let's understand that as well. So when we talk about the initialization, as I have put an array here, a data structure here, the automatic initialization index is going to be the first index. So when we do the iteration, when this for loop is going to execute, it is automatically going to initialize a temporary variable with the value at the first index, which is the index 0. As you know, that array is a 0 index based structure. Then comes the condition part. So the condition evaluation is going to be again based on the size of the array or the size of the data structure which you are using. It is going to start from the first index, which is the index 0, and it is going to iterate till the array's last element is reached. So technically start from the index 0 and go till the last element. That's your evaluation condition. And then comes the increment part. So at each step, after it has successfully accessed the first element, automatically the index is going to be updated to pointing to the next element. So if it starts from here, once the first step iteration is complete, I is automatically going to be incremented to index 1. And then it will basically, this I will be holding 2. Then in the next iteration, the same I is going to be holding 3. Similarly, I will keep holding the new value of the collection item one by one till the collection item's last element is reached. So this is the basic premise, that you can write a collection variable here and keep iterating over it, and this whatever variable you write here will hold the current item's value one by one. So in the first step, this I is going to hold 1. In the second step, this I is going to hold 2. In the third step, this I is going to hold 3, and so on and so forth. That's the basic idea. So now let's run this program to see what kind of output do we get. So you can see we basically are able to print all the elements of the array. And that's probably one of the most popular usage as well, that if you want to just print all the elements or access all the elements of a array or a collection one by one, then just use enhanced for loop. So you can see at each step, it is printing the value of I, and the value of I is basically the subsequent elements of the array. That's the whole idea with enhanced for loop. Under the hoods, if we talk about how does it work under the hood, it is actually using the classic for loop construct itself. But for developers, it is making it easier because it knows that if you are iterating over a collection, you will start with the first element and you will go till the last element. So it knows the initialization value, the termination condition, and it also knows the increment condition. And that's the reason you will use enhanced for loops in Java for iterating over collections. Hello guys, let's get started with nested for loops in Java. So in front of you, you can see an example which I have prepared for nested for loops. And in this particular example, I have created a two-dimensional array. As you can see on the line number 6, I have created an integer array and I have put two square brackets here, which are basically symbolizing that this is a two-dimensional array. So this two-dimensional array is going to hold technically a 2D matrix. And we are going to use the concept of nested for loops to print this 2D array in a 2D matrix style where you will be able to see the rows and columns clearly. Let's first try to interpret this particular 2D array. So we have a curly braces outside, and then we have these three inner elements, which symbolizes three rows basically. So this is the first row, this is the second row, and this is the third row. And then each of the rows have three elements each, which symbolizes the column values or the item values. So it's basically a 3 into 3 2D array, which has three rows and three columns. So we can say that this is basically a 3 into 3 array, which has 3 dimensions on the row side and 3 dimensions on the column side, or just a 3 by 3 matrix or 3 by 3 2D array. So as we know that in case of arrays, everything starts from 0. So technically, if we talk about the indexes, it would be the index 0, index 1, and index 2 on the row side, and similarly index 0, index 1, and index 2 on the column side. So that's something which you should remember, because we are going to use this particular concept when we write the for loop. So let's try to write the for loop now. If you look at line number 8, we put this keyword called for, and then we write the initialization. So we say int I equal to 0. Then we are writing the termination condition, and we are saying run this particular loop, run this whole loop which ends at line 13 till I is less than 3, and keep incrementing I at every step. That's what I'm doing in the line number 8. Then inside the for loop, I'm writing another for loop which has another different variable called j. It can be anything, you can name it anything you want. And this also starts with 0. And this also has a similar condition which says run this particular loop, the line 10 basically, or this loop which is signified by this curly braces. Run this particular loop till the time the value of j is less than 3, and keep incrementing j at every step. And at line number 10, print the element of array which has the current value of I and the current value of j. These are basically the positions. These are not the elements. The element would be represented by this hole, but print the element which is at current I and j's position values. That's what this code means. So let's try to do a dry run on this particular code to understand how this is going to work. So at first we have I equal to 0. 0 is less than 3, and it goes inside. It initializes j as well with 0, and 0 is also less than 3. So this condition went true. That's why we went to line number 9, and line number 9 condition also went to true. So we went to line number 10. Remember that in this particular case at line number 10, the values of I and j are 0 and 0 respectively. And we are saying print the array of 0 and 0. So 0th rows, 0th column element should be printed. So this is the 0th row because this is the first subblock, and this is the first element. So in this case, in line number 10, 2 should get printed. Then it goes here and it increments the j to 1. So 0 plus 1 becomes 1. It again checks the condition, is 1 less than 3? So yes, 1 is less than 3. It goes here. Remember, it did not go up at line number 8. It just came back from line number 9. So when it comes here, I is still 0, but j has moved from 0 to 1. So now we are trying to access the element which is at 0th row, first column, which is going to be 7. So 7 is going to get printed. Similarly, on the next iteration, j is going to get incremented from 1 to 2. And again, the condition will be evaluated. So 2 is less than 3. All good. It will again come back to line number 10. And now it will say print the value of 0 row, third, or the second column, or the third element. So 0th row, third element, which is the 9. So 9 will get printed. Then again, j will be incremented and j will become 3. 2 plus 1, 3. And now the condition will be evaluated. Is 3 less than 3? No, it is not less than 3. The condition becomes false. So it breaks out of the loop, goes to line number 12, prints an empty line because we are not writing anything here. So it will just print a blank line. And now it will go back to line number 8's condition, and it will do an increment of I. And now I will move from 0 to 1. And now the evaluation will happen. Is 1 less than 3? Yes, 1 is less than 3. So it will again go to line number 9. Again initialize j with a fresh 0. The previous j got destroyed the moment you came out of the loop. So this is a new j. So this j again gets initialized to 0. 0 is less than 3. It goes here. Remember, I was 1 in this time. So now it will print the value of this 2D array, which is sitting at 1, 0. Basically second row, first element. So second row, first element, which is 3. Again, j is going to get incremented and it will become from 0 to 1. So 1 is less than 3. Yes, it will again come here and it will print the value of the array, which is sitting at array of 1, 1 for a row equal to 1 and column equal to 1, which will be 6. Similarly, j will get incremented again. Again, 2 is less than 3. Come back here, will print 1. Then again will increment j. J will become 3. 3 is less than 3. No, it's false. The condition is false. So it jumps out of the loop, goes to line number 12, prints a blank line, again goes back to 8, line number 8, increments I, and I now becomes 2. 2 is less than 3. Yes, it will again go here, initialize j again with 0, and again does the same thing for the row 2 and column 0, 1, 2. And again, it will come out of the loop. This time, again, when it will go here, the value will become from 2 to 3, and 3 is not less than 3. So then it will break out of the outer loop. So the idea is execute the inner loop for every value of the outer loop. Remember this line, because that is how you will be applying your knowledge of nested for loops to be used in certain condition. So whenever you have a scenario where you have to iterate over a collection based on a certain value of another collection, then you can use nested for loops. Or you have a scenario where you have to iterate over 2D or 3D arrays. For example, if we were dealing with 3D arrays, then you would have seen 3 nested for loops here, and where it will apply the same logic that iterate over all the collections, all the values of the inner loop on a particular value of the outer loop. Then increment the value of the outer loop and do the same thing again. Iterate over all the values of the inner loop based on a fixed value of the outer loop. So let's run this program and let's see what kind of output do we get. So like I said, our motive, our target was to print this in a matrix style. And you can see that it is printing in a sort of a matrix representation. So the first row gets printed here, then the second row gets printed here, and then the third row gets printed here. If you try to decipher it, it will work exactly the same way as I explained. So I equal to 0, 0 less than 3, condition becomes true, comes here, j equal to 0, j less than 3, condition becomes true, comes here, prints the array of 0, 0, which is 2, then prints the array of 0, 1, which is 7, 0, 2, which is 9, then j becomes 3, it breaks out of the loop, goes up here, I becomes from 0 to 1, 1 is less than 3, yes, again comes here, reinitializes a fresh for loop with a new j setting to 0, and it will print the array of 1, 0, 1, 1, 1, 2, then similarly array of 2, 0, 2, 1, 2, 2. So that's basically what we are doing. We are picking the first row and iterating all elements of it, picking the second row, iterating all elements over it, and so on and so forth. You can do this for any n-dimensional kind of array or a collection.
And with that, we have come to an end of this tutorial. If you have any queries regarding the topics covered in this tutorial, then please feel free to ask them down in the comment section below. Our 24/7 support team will be happy to resolve all your queries. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.